Our problem says, suppose that the supply and demand for crab meat in a local fish store are related by the following equations. The supply equation is P equals 6Q plus 2, and the demand equation is P equals 22 minus 2Q, where P represents the price in dollars per pound, and Q represents the quantity of crab meat in pounds per day. Part A says, find the price when the demand is 3 pounds per day. Well, Part A is only talking about demand, so we're only going to use the demand equation. It says find the price, find P, when the demand, which is Q, is 3. So find P when Q is 3 means plug in 3 for Q and now follow the order of operations. We do multiplication before subtraction. Now we do the subtraction and we get P equals 16. Remember, P it told us was in dollars per pound. Part B is talking about both supply and demand. So we're going to use both of our equations here. We're going to use the supply equation, P equals 6Q plus 2, and we're going to use the demand equation, P equals 22 minus 2Q. It says find the quantity, meaning find Q, when P, the price, is 21. So we plug in 21 for price in both equations because it asks us to find not just the quantity supplied, but also the quantity demanded. So to solve the equation on the left, I'm first going to subtract 2 from both sides of the equation. Then I'm going to divide both sides by 6. If you do 19 divided by 6 on your calculator, you're going to get 3.33333 repeating. Remember, an infinitely repeating 3 is another name for the fraction 1/3. So we get 3 and 1/3, and remember, quantity is being measured in pounds per day. Let's find the quantity demanded. If I subtract 22 from both sides of the equation, 21 minus 22 gives me a -1 on the left side. And now to get Q by itself, I divide both sides by -2. A negative divided by a negative is a positive. 1 divided by 2 is 1/2. So the quantity demanded at a price of $21 per pound is a ½ pound per day. Part C is asking us to graph. So here, remember, we used to talk about y equals mx plus b. Y was the vertical axis. Which variable is playing the role of y here? Well, p is where the y normally is. And q is right after the slope, which is where the x normally is. So we're going to have price on the vertical axis, and we're going to have quantity on the horizontal axis. Now, to be able to go all the way up to a y-intercept of 22, I'm going to go in threes: 3, 6, 9, 12, 15, 18, 21. That would be 24 right there. So let's go ahead and graph the supply equation. The supply equation has a y-intercept of 2, which would be right there, and its slope is 6. And remember, 6 is the same as 6 over 1. So that means if we go up 6 from y equals 2 to y equals 8, we go to the right 1, and this then becomes our supply equation. Now, if you're wondering why it's going infinitely to the right and not infinitely to the left, if I go to the left, then I'm moving into the second and third quadrants where I would get negative prices and negative quantities, which make no sense in a business problem. So that's why the graph ends at the y-intercept 0, 2. Now let's graph the demand equation P equals negative 2Q plus 22. The y-intercept is 22, which would be right there, and the slope is negative 2 over 1, which means you would go down 2 to 19 and to the right 1, and you could then get your your demand line, which is going to look like this. And that is not going to go infinitely, because if it goes into the fourth quadrant, you would get negative prices, which make no sense. So here we have our demand graph, and here we have our supply graph. On a test, I'm going to supply a printed graph on the test for you. I'll supply axes on the test. You can use the side of your student ID as a straight edge so that you can get an accurate graph. Finally, part D. Part D says find the equilibrium quantity and the equilibrium price. Well, you have equilibrium when supply is equal to demand, which in this problem, we're told the supply is 6Q plus 2, and the demand is 22 minus 2Q. So we now need to solve this equation. First thing I'm going to do is I'm going to add 2Q to both sides, giving me that. Now I'm going to subtract 2 from both sides. I get 8Q equals 20. And I'm going to divide both sides by 8. 20 divided by 8 on your calculator is 2.5. This is a value of Q. Remember, they told us that quantity had a unit of pounds per day. So that is our equilibrium quantity. How do you find the equilibrium price? Well, you can use either equation. It makes no difference. I'm going to use the 6Q plus 2, and where I used to have the Q, I'm going to plug in 2.5. Multiplication comes before addition, so first I do 6 times 2.5. That is going to give me 15. Then I add the 2 to it, and my equilibrium price is $17 per day. Now, you would have gotten the same equilibrium price if you'd taken your 2.5 and plugged it into the demand equation. 22 minus 2 times 2.5 also results in 17. So what this tells us is if you set the price of the crab meat at $17, I wrote per day, that should be per pound. If you set the price of the crab meat at $17 per pound, your supply and demand will be exactly equal, and that would be a supply and demand of 2.5 pounds per day.